What if the most powerful telescope in history has just revealed something we were never meant to witness? What if everything we've ever believed about the origin of the universe, about time, space, and the very nature of reality is now beginning to collapse under the weight of new, unexplainable evidence? The James Webb Space Telescope, designed to capture the faintest echoes of the cosmos's earliest light, has returned data so unsettling that a Nobel Prize-winning physicist has come forward with a chilling, singular message: this is not our universe. What exactly did Webb find at the very edge of everything? And why are scientists warning that these findings could rewrite the foundations of cosmology as we know it? Stay with us, because what you're about to hear changes everything. In a seemingly unremarkable corner of the sky, flooded with ancient light, the James Webb Space Telescope captured what initially appeared to be a simple yellow smudge. But when astronomers examined it more closely, their assumptions crumbled. That tiny glowing spot wasn't just another distant galaxy, it was the most distant galaxy ever detected, formed a mere 290 million years after the supposed beginning of the universe. But here's the part that defies logic. This galaxy is far too massive, far too luminous, and far too evolved to have formed so soon after the Big Bang. According to our current models of physics and cosmology, there simply wasn't enough time or raw material in the early universe for a structure like this to exist, and yet there it is. And what's more, it's not an isolated case. Webb has now found dozens of such galaxies, each one a cosmic paradox, each one breaking the known rules of early galactic formation. As scientists pushed deeper into Webb's data, things got stranger. Some of these primordial objects aren't just unexpectedly large, they're utterly foreign. Unlike typical galaxies, which convert about 10% of their gas into stars, Webb found at least 3 galaxies that have apparently turned 100% of their matter into stars. No gas, no dust, just raw, radiant starlight. That's not just unusual. It's considered impossible by every current theory of how galaxies form and evolve. This has led researchers to an even more disturbing question: what if these aren't galaxies at all? What if what we're seeing isn't a glimpse of the early universe, but something entirely different? Could these be structures from another dimension? Remnants of a previous cosmos? Or are we witnessing some form of intrusion from a neighboring universe? To understand why these discoveries are shaking cosmology to its foundation, we need to talk about the Hubble sphere and the observable universe. As space expands, the farther an object is from us, the faster it recedes. Eventually, objects move away faster than the speed of light. That boundary is known as the Hubble sphere. According to conventional wisdom, we shouldn't be able to observe anything beyond it. Yet we can, because the boundary of what we can observe is constantly stretching as space itself expands. Still, beyond that ever-growing edge lies a terrifying concept, a region of the universe that we will never reach and that will never reach us. And somehow, the James Webb Telescope is now detecting light from those unreachable zones, light that by all accounts should never have arrived. There is only one possible conclusion: we are seeing beyond the limits of our universe, and no one knows what's on the other side. Webb's data is pushing scientists to consider what once seemed unthinkable. What if the universe never had a true beginning? Some Nobel laureates are now openly questioning the Big Bang model. If galaxies could form faster than physics permits, if light can reach us from realms supposedly beyond our reach, if structures can appear that defy time, mass, and scale, then maybe our understanding is fundamentally flawed. Maybe the early universe we think we're seeing isn't early at all. Maybe it's not a timeline, but a fracture point of overlap, where two universes collide or bleed into each other. Or worse, perhaps something older, something alien to our reality, is seeping through. Whatever this is, it doesn't fit within any model we've ever made, and perhaps it never will. One of Webb's strangest and most overlooked discoveries wasn't a picture, it was a sound, or rather, a frequency. While analyzing the ambient noise of deep space, Webb's instruments picked up a faint, rhythmic oscillation. It didn't match any known cosmic phenomenon. It wasn't the pulsar, nor gravitational waves, nor distortions in the cosmic microwave background. It was something else, something regular, repeating with precise intervals, as if it were generated. Some astrophysicists have begun to call it the heartbeat beyond time. Others remain cautious, proposing that it might be the trace of exotic matter, something theorized to exist only beyond the physical limits of our known universe. But here's the unsettling part. This rhythm isn't random. It follows a distinct mathematical pattern, almost as if it were encoded meant to be discovered. But that's not the only imbalance Webb has revealed. In the deepest reaches of space, galaxies appear to possess gravity strong enough to bend light, warp space, and influence surrounding structures, yet no visible matter accounts for it. This isn't just dark matter, it's something stranger. Webb seems to be detecting immense gravitational distortions with no corresponding mass. These phantom mass fields, as some are calling them, behave like invisible fingerprints, pressing into spacetime from sources we cannot locate. And that has led some theorists to suggest the unthinkable. What if we are seeing the gravitational shadow of another universe colliding with our own? Could everything we observe have a mirror image we can't see, not metaphorically but physically? A long-dismissed French theory is now gaining renewed attention: the idea of a mirrored universe where time flows backward and the laws of physics run in reverse compared to ours. Why the renewed interest? Because Webb has detected peculiar behaviors in particle spin and the rotational patterns of distant galaxies. These patterns suggest a symmetry-like to overlapping systems, one pulling in one direction, the other pushing back. It's as if our universe is being gently tugged by another one, just out of reach. If this is true, we may not be alone in the multiverse. We may be entangled with a shadow version of ourselves. In one final and chilling twist, Webb's instruments captured a light signal from the farthest edge of the observable universe. It should have faded and disappeared, as most distant cosmic light eventually does. But it didn't. Instead, the light reappeared from a different direction, from a different time, but carrying the same spectral fingerprint. It was as if the light had gone out and bounced back. What Webb had recorded was a cosmic echo. But echo of what? There are only two explanations. Either the light circled back around a closed, curved universe suggesting space is finite, or it hit something else, something at the very edge. Something capable of reflecting light. Something that should not be there. The James Webb Space Telescope was built to look backward in time, to reveal how the universe began. But instead, it may have shown us something far more terrifying. That our universe is not alone, that impossible. Galaxies, phantom mass, reversed patterns, unknown rhythms, and unexplained echoes are not anomalies but signals that chip away at everything we thought we knew. The comforting illusion that we understand where we are, when we are, and what we are. A Nobel Prize-winning physicist warned us, this is not our universe. And maybe that's the truth we were never meant to face. Perhaps we are drifting on the edge of something vast, ancient, and utterly indifferent. A deeper framework, a larger existence, a universe behind the universe. So now the real question isn't whether we're alone in the cosmos, it's whether we're even in the right one.